This video is going to be an introduction to complex numbers, but before we actually get to the imaginary number I need to make sure that we're thinking about numbers in a specific way. So if I write the number 3, we can think of it as representing a quantity. For example, maybe we have it represent 3 apples. But for the course of this video, not only do I want you to think about numbers in terms of quantities, I want you to think of what they do to other numbers under multiplication. As an example of what I mean, let's start with the equation 3 times 2 is equal to 6. So here I'm thinking of 3 as acting on 2 and stretching it out to yield 6. I'm going to give a visualization to help us understand what's going on. So here we just have a regular number line. And what I'm going to do is I'm going to add an arrow that points from 0 to 2. Okay, so this arrow down here is supposed to represent this number 2. So it's an arrow pointing from 0 to 2. And what's going to happen is that when we multiply by 3, we're going to stretch the arrow out. So we're going to have some action where this thing gets stretched out. Just like this. So for at least the course of these videos on complex numbers, that's how I want you to think about numbers. Not only in terms of quantity, 3 can represent a number of apples, but I also want you to think of it in terms of its action on their multiplication. So here I want you to think of this. 3 triples the length of numbers. Now I want us to see how we can interpret multiplying by negative numbers. So we'll start with negative 1 times 2, which we know is equal to negative 2. And again, I'm going to try to give some geometric visualization to help us understand what's going on here. So again, we'll build a number line. And I want to start by adding an arrow pointing from 0 to 2. So this is the number we're starting with. We're going to start with this 2 just like this. Now we want to end up over here, and the way we're going to get there is by rotating around in this direction. So that's how I'm going to think of negative 1 acting, is it's going to send this arrow over like this. And I want to point out that this is a 180 degree angle. So in here we have 180 degrees. That's how I'm going to think of negative 1, is negative 1 rotates, whatever this means, rotates numbers by 180 degrees. And that's how we go from 2 to negative 2. Let's do another example. This time we'll have negative 1 times negative 1 times 2, which gives us again 2. I'm going to build the number line and the arrows again and see what's happening to the arrows. How do we explain why multiplying by negative 1 twice gives us back the number we started with? So here we have our number line. And let's build an arrow to represent this number 2. Now we're going to apply the first 180 degree rotation. So initially, from this negative 1, we have a 180 degree rotation. And now we're thinking of numbers in terms of their action on other numbers. We have to multiply by negative 1 again, so we're going to apply another 180 degree rotation. So now this negative 1 applies another 180 degree rotation, like this. So here we have another 180 degree rotation, and if you look, the total rotation is 360 degrees. That's why we come back to where we started. We have 180 degrees plus 180 degrees gives us a full circle, 360 degrees. This brings us to the main topic of this video. We want a number, which we'll denote by I, such that I squared, that's I, times 2 gives us negative 2. So how are we going to make such a number? Well, let's go back to this whole arrow thing, the way we think about numbers. So again, we're going to build our number line. And let's build an arrow to represent 2. Okay. We want to end up over here at negative 2. And thinking about back to the last example, negative 1 rotates by 180 degrees. And when we multiply by negative 1 twice, we add those angles. That's how we ended up back at 2. We had 180 degrees plus 180 degrees to yield 360 degrees. We want something that when we apply it to 2 twice, we end up with a 180 degree rotation. So what we're going to do is we're going to rotate 90 degrees. That'll be the first eye, and then we'll rotate another 90 degrees. Let's go ahead and do that. So the first eye will act like this. We have a 90 degree rotation. All right. Now we apply another 90 degree rotation. So here we have 90 degrees. We're going to apply another 90 degree rotation coming from the next eye. So again, we have another 90 degree rotation. We add them, we get the full 180 degree rotation. That's how we end up with I times 2 is equal to negative 2. And this is how I acts on numbers. So I rotates numbers 90 degrees. Let me put that in quotations because you may be wondering, what does it mean rotate? Well, just accept the analogy for now. I rotates numbers 90 degrees. I'd like to point something else out. When we do 3 times 1, well, we get 3, of course. But I want us to go back to our arrows and see what is happening. So first, we build on our number line. And then we're going to build an arrow to represent this number 1. So this arrow is for this number. Now we're going to stretch it out. Remember, so we have this action. When we multiply by 3, we're going to have this action where we stretch out. Just like this. Okay. Notice the arrow now points at 3, of course, because it's 3 times 1 is equal to 3. And the point of this is that when we multiply 1 by 3, where the arrow gets sent to is where we write 3 on the number line. It seems a little trivial, but it's going to be necessary for our next step. Now let's look at I times 1, which of course will just give us I. Let's see what's happening on our number line. So we'll build the number line. And we want to build an arrow to represent the number 1. Now remember, when we multiply numbers by I, we're going to rotate them 90 degrees. So let's go ahead and do this. So we performed a 90 degree rotation. This rotation is what happened when we multiplied by I. And using our observation from before about multiplying 1 by 3, we point to the number 3. Where this arrow points is now what we're going to call the number I. So I'm going to build a whole new number line pointing up and down. And where this arrow points, I'm going to call I. And then we can add more points. So this one is 2I. Down here, we have negative I. And then negative 2I. So we can combine these two number lines. We have the horizontal real line and this vertical line of imaginary numbers. And it gives us what's called a complex plane. And points in our complex plane can be, they don't just have to be on these two lines, they can be somewhere in here. For example, we can go over 2 and up to I, and we can have a number that we'll call, well, we'll say right here, and we'll point from there to there. And this number is called 2 plus I. We go over 2 in this direction, and then up I in that direction. Let's look at one more thing. When we do I times 1, of course, we get I squared, right? It's just multiplying anything by 1 gives us that number back. So over here, we should have I squared. Let's go back to see what's happening with our arrows. So I'm going to build a complex plane. And now I'm going to build an arrow over here that represents the number 1. Now let's multiply by the first I, which is going to give us a 90-degree rotation. And now we'll multiply by the second I, giving us another 90-degree rotation. But now you see the arrow points to -1. So what we actually have is I squared is equal to -1. This is a pretty important equality. I'll box this around. Okay, I think this is a good place to end these videos.